Welcome to the Women in AI Research podcast. I'm Ekaterina, and I'm joined by my co-host, Malika. Today's episode is all about LLM reasoning, reasoning evaluation, chain of thought, complex and neuro-symbolic reasoning, and explainable AI. With our guest today, we will explore why it is crucial to move beyond correctness to evaluate the process of LLM reasoning, how brain teasers review the balance between brute force and the insight-driven thinking, and what reasoning benchmarks like Folio and the P-Folio teach us about logical and symbolic reasoning. We will also dive into how insights from cognitive science and human-like reasoning can inspire more interpretable, explainable, and trustworthy AI systems. And beyond the technical, we will hear about our guests' personal experiences, things that encourage and discourage her in her research journey. And our guest today is Simeng Sophia Han. Simeng is a final year PhD candidate at the Yale University, advised by the Professor Arman Cohen. Simeng focuses on LLM complex reasoning, neuro-symbolic reasoning, and reasoning evaluation. She's currently also a research scientist intern at the AI Frontier reasoning team in Meta. And previously, she interned at Google DeepMind and the AWS, where she worked with some fantastic teams to advance reasoning capabilities in LLMs. Simeng is passionate about building systems that can think more intelligently and communicate their reasoning, whether through natural or symbolic language. And she believes that powerful AI should also be transparent, interpretable, and aligned with human values. Welcome, Simeng, to our podcast. And let's start at the beginning of your research journey. So could you share a little bit about your journey into NLP and AI research? Specifically, like I'm interested in how your early experiences might have shaped your perspective on problem solving and AI.
Yeah, hi everyone, I'm Simeng Sophia. I'm very excited to be here to talk about my research and my previous experience in NLP. So I did my undergrad in computer science, and even before that, I participated in math and physics Olympiad competitions in high school. And I think back then that it was an early stage when I was trained to solve very hard problems. In some sense, I think it's similar as complex reasoning that these LMs are now trying to solve. And in my high school, I think there was a teacher that inspired me a lot, a math teacher. So he taught us that when we are trying to solve a problem, we should not actually try to copy paste some thinking traces or like some thinking strategies directly from the questions that we have done before, but instead we should actually start from the problem, then try to observe the patterns of the problem. And given all of this and like the advancement of the computational methodologies, but I think there can still be some very interesting phenomena where the LM can actually adopt from how humans think. It could be very helpful also to give it a lot of intuition and also making it think about the nature of the problems.
Thanks for sharing that. Yeah, it's resonates a lot with my background. Like, I also participated in math Olympiads, and I totally agree with you. Like, building that problem solving mindset was very helpful throughout my journey. You already covered my next question, but I re-asked that. You might have different answer for it. Was there anyone who encouraged or perhaps discouraged you early on this journey? How did that shape where you are today?
Yeah, maybe I can go a bit more in depth into that. The math teacher that I mentioned. Yeah, during high school, he really taught me the problem solving mindset that I have not learned actually anywhere else at any stages of my career. Yeah, and so that was a very, I think, significant person who influenced me a lot. And in university, there was also I had an advisor, a research advisor. During that period, he taught me a lot about NLP research, like how to think about the architecture of the problems and also the laws of the neural networks. So he was not just an NLP researcher, like he was also very expert in linguistics and machine learning. Yeah, but also taught me how to think about where are the shortcomings of the the current methodologies and how to really improve them.
When I talk with senior researchers or people in their last year of PhD, they usually say that their first research was not their best research. I have the same question for you. How has your understanding of your research topic evolved since you started your PhD? We'd love to hear about a time when your experiments completely failed or gave surprising results. What did you do next?
I think for me, my first research was actually a good research for me. That was a very difficult question. Yeah, back then, and we poured a lot of efforts into it. Specifically, we were trying to build a benchmark folio, and so we didn't really use a lot of computational resources, but we used a lot of human resources, like a lot. So so that project at the beginning, it was only a few people uh, in doing machine learning and NLP, yeah, I still remember my advisor back. He gave me he connected with me a lot of the senior researchers in the field, and we had a lot of interesting discussions. And the first review for that project was actually, I think, quite bad. Yeah, I think now thinking back, it's like more harsh than it can be, but the reviews gave us a lot of insights for improvement where we submitted to the tackle. Yeah, and but for improvement, we actually had to rethink the project a lot. So back then we annotated for around 1,000 examples, and based on the review, it seems that like more than 2/3 of the examples need to be redone or need to be totally revamped in order to make this benchmark even a valid benchmark, and more so having it published in a good venue. Yeah, and so that was kind of a very, I think, difficult period for me. Yeah, but again, at that point we had, I think that was one of the advantages of being in a more comprehensive school where people work on everything, because we had a lot of interdisciplinary support. Yeah, so I was working on logical reasoning, but I'm not really a logician, and there were some questions that I couldn't solve, but we resorted to a logician in the university, and we tried to make the benchmark like the both the logic part and also the language part much better with a lot of interdisciplinary support, like people working on English literature, and also we did a very large round of debiasing. Like I think in my opinion, it was a very fundamental building block for the next step of improvement. But the revamping was very significant. Yeah.
Can you share with us like how much time it took you to address all the feedback that you got from that first initial sufficiently negative review?
Yeah. I think it took around for half a year. Yeah, but back then I still remember there was a moment because we added a lot of people from different fields, and then when such kind of interdisciplinary effort happens, important question is to keep the scope within NLP. While there are so many people from other fields, and it was a significant amount of I think management work to do as well. But thinking back, that was very interesting and important project in my PhD.
You have also mentioned those benchmarks that you've worked on, so and in general reasoning evaluation work. So I would like to dig a little bit deeper into that part of your work. So let's start with the paper that is called Creativity or Brute Force, using brain teasers as a window into the problem-solving abilities of large language models. So your work on LLM reasoning evaluation challenges the conventional metric of whether the answer is correct. It's a very simple, like, accuracy metric. Can you elaborate a little bit on why understanding of how a model arrives at the answer is advancing the understanding and design of LLMs? Why it is important to figure out what is the reasoning process instead of just using the accuracy metric?
Yeah. That's a I think very interesting problem to discuss about as well. And maybe first of all, I think accuracy is a, I think, very important metric. Like, and it's like having this type of straightforward metrics is very important for the mirroring the development of language models in a relatively straightforward manner, and I think greatly helps the progress of the field. But I think we may have come to a point where like all like marrying this progress and also this kind like a lot of algorithms are using accuracy or final answer to improve their performance. And I think it could be that some other metrics or mirroring the reasoning process is very important because like we can never truly understand what these models are thinking about unless we look deeply into their reasoning traces. And this kind of error analysis or qualitative of analysis is kind of important in the study of NLP. For in my project, I try to study a lot of aspects of the reasoning process and also some aspects that are related to the problem-solving process itself. And some of these inspirations came from my understanding about natural language that happened at a like maybe very early stage when I was still working on parsing, and also happened based on my experience with problem solving. And so I found that semantic parsing is important, like parsings. And in this case, I identified a kind of different semantic parsing paradigm that is from most of maybe the semantic parsing definition, where the natural language is parsed into symbolic language. So in this case, we found the problems as since brain teasers are usually written in a narrative style. Here, semantic parsing would mean to parse the narrative style questions into a more math problem style question. So here, after semantic parsing, the natural language is still there, but the problem is made into a more concise form that also contains some math equations. Yeah. And the motivation for this, for example, is that maybe language models have seen a lot more math style questions, or it is used to like invoke its math thinking when it sees actually a math problem, and also this kind of semantic parsing helps it to makes the problem easier to understand to the model, and for it to actually abstract the math equations. Yeah. So that this is one of the aspects that I studied with brain teasers.
Cool. Yeah, as you said, you use brain teasers as an ideal medium to study multiple layers of the LLM reasoning process. So what are specific aspects of brain teasers allow you to distinguish between a model solving through brute force search or guessing versus relying on a flash of insight or a more structured reasoning path as humans often do?
Yeah. So I like brain teasers a lot because I'm solving brain teasers do this is a more like no, doesn't require a lot of knowledge. Actually, there are not a lot of theorems we can adopt, but sometimes it's just relies on the intuition or observing the problem patterns. And that I find specifically interesting because in this case, we're trying to develop, find out what are the underlying heuristics, or what is the nature of the problem. So by mentioning heuristic, so this is a new understanding that I had recently that is not on the paper, but I recently read in cognitive science about fast and frugal heuristics. So here they say so for example, a very like real life problem, if someone throws at me a ball and I'm trying to catch it, then in order to catch it, there are two ways. One way is to do it with some algorithms, and in this case, the algorithm would be to calculate the trajectory of the ball. And in order to calculate that, since in the real world there are so many different factors that can affect the ball's trajectory, like the wind speed, maybe even humidity, and and so this is like a very difficult task when we do it algorithmically, or in some sense when we do it in a brute force way. But we as humans, we we have kind of this instinct, or we developed a much more efficient method, which is just to keep our eye on the ball and try to follow its path with our eye. And so instead of really calculating trajectory and put our hand where the ball is supposed to fall, we just keep our eye on the ball, and we are able to estimate where the ball is coming from. So this is what they call the fast and frugal heuristics. So that's this kind of methodologies, they usually provide valid shortcuts in order to arrive at a problem in a more efficient way. Maybe going a bit more concrete in math. So this could refers to, so if for example there's a problem where there are the problem space requires us to search over a million choices. But here, the fast and frugal heuristics, if we find them, they will be able to narrow down the problem space, and maybe one hint can makes a problem space from 1 million to maybe like 10,000. And another hint or another heuristic that we discover from a problem can make the problem space from 10,000 to 100. Yeah, and then to conduct the search, it would be much faster than if we just search over 1 million choices.
Right. So it's something like fast thinking and yeah. Let me clarify just one thing here. You mentioned those two types of heuristics to, let's say, with the ball to calculate the whole trajectory and just to observe the ball and react when necessary as the fast version. Are both of those heuristics used by humans as well, or it's humans tend to use one of them more than another?
Yeah. I think that is a very interesting question. And I think I don't have a fixed answer for that, because I feel that humans also use both, actually. Yeah. And it's oftentimes oftentimes maybe humans will try to decide which one to use beforehand, or it could be that maybe after an attempt at one, but after maybe a failed attempt at one, then we choose to attempt the other. Yeah, so yeah, I don't have a fixed answer which one humans use more, actually, but I feel that maybe the other way is more efficient and maybe more could be considered as more clever. Yeah.
Right, that's very interesting. And then if we switch from humans to actual brain teasers that you used in your work, is it necessary, you think, for solving brain teasers to distinguish between those two different approaches and then choose one or another? And maybe you could illustrate with the example of how that distinction looks like.
Yeah. So for give an example, I find one example very like illustrative, but also straightforward, is to okay. So this problem is like if we can only use the number 2, and we can use any mathematical signs or functions or symbols, how do we get a 5? And in this problem, we can either enumerate all the mathematical signs and symbols and functions there are, and do a brute force search. But we can also try to try to think about what are the connections between 2 and 5. I think so. By solving the problem this way is much more efficient, but it requires a lot of us to observe the patterns of the problem in order to arrive at the final answer. Yeah, and I guess different humans or different language models may also approach this problem in different ways. Sometimes it could be a trial and error, where maybe after we think about after we try a few mathematical signs and symbols, we realize, okay, this is not a good strategy, but during that process, some of the patterns can be identified for the final solution.
Cool. As you already mentioned, your work aims to use insights from cognitive science to inform better language model designs. So what are some initial observations or hypotheses that you've formed about the differences between human and LLM problem-solving approaches that could lead to new architectural or training paradigms? I think you already mentioned some of those, but let's go deeper into it.
Yeah. So I'm not a cognitive scientist, but I've been trying to identify how we can use the inspirations found there, because they have, I think they have a much better understanding of human problem solving. And some of the some I have an ongoing work that utilizes specific on the pattern that I identified, like creativity. And to try to use creativity to improve human problem, to improve model problem solving. Previously I also had another work called hybrid mind. And in that work I try to develop some meta thinking strategy. That enforces the model to think about the problem strategy itself before actually solving the problem. So these are some of the inspirations. And also recently I also been exploring the fast and frugal heuristics from the cognitive field.
That's super interesting. Just one follow-up question. When it comes to reasoning, do you think that you approach that challenge in general from the perspective of the cognitive science of how people do that? Do you think we should necessarily directly copy the human like way of reasoning into AI systems, into LLMs, or there could be other ways as well?
That's a very very interesting problem. I think first of all it depends how humans solve problems. I'm not sure if this can be completely, probably cannot be completely modeled in a computational manner yet. So this is and that's that but LLM on the other hand, as a substitute, can actually already solve a lot of problems. And this may show that, this also based on the idea of language model, where the models are trained to do next word prediction. And language model is also very an important concept in the field. And just early on, it was usually only used to predict the next token. So I think I don't think that entirely mimicking human ways is the ideal solution or the ultimate way. Like if we think about the history of the technology, usually when we try to build something that is completely animal-like, it sometimes fails. But when we apply some more like physics or maths, then we arrive at better solutions. So here I think we need to keep in mind how humans problem solving is efficient. Both like data is very data efficient, and also the thinking process can be creative and efficient. And I think and also can be generalizable, like to newer and more difficult problems. So I think it's important to keep all of this in mind while we are developing new computational models, but not exactly copying from human.
Right. That's interesting. And yeah, to think about human-like and machine-like reasoning, I want to discuss with you your another work on P-folio. It's called Evaluating and Improving Logical Reasoning with the Abundant Human Written Reasoning Chains.
Yes.
It was published at the EMNLP. So there you annotate a chain of thought traces to make models explain their own reasoning, right? And you are collecting human written reasoning chains for this benchmark. So can you tell us what are the challenges in collecting all those chains for the benchmark like that?
Yeah, I mean for collecting human reasoning chains, or yeah.
What are the challenges for collecting human reasoning chains, and how do you see then the value of those human written reasoning chains in training the model?
Yeah, I think collecting the human reasoning chains was difficult partly because that some some of logical reasoning questions can be like the questions themselves are already quite semantically complex and or syntactically complex. Then when we ask humans to solve those issue like to parse those syntax and semantics and also derive the logic, it can be a very challenging task for humans. Yeah, and in those cases, I actually found machines, when we parse the problems into symbolic form, machines do it in a much more efficient manner, because in a symbolic form it's more structured, and they when the machine or like a symbolic engine is doing parsing and reasoning over that, it only needs to consider the skeleton of the structure of the sentences without actually thinking much about the semantics. Yeah, this is especially true because this is a logical reasoning task, and in this case, semantics don't matter much as logic. Yeah, and yeah, so that was a challenge for a human, and also a very interesting distinction from machine. Yeah.
So, how do you envision researchers leveraging these explainable models to open the black box of LLMs?
Yeah. So I think for opening black box of LMs, there are two active lines. One is to directly use natural language, like ask language model to write the explanations, and think this if the language model can output explanations, then it's explainable. I personally find this line very interesting because it's also very effective to in practice. Like when we are able to read the LM outputs that are written in a human understandable way, is like it's very straightforward for us to know. Okay, it's it's explainable. And the other line is to actually use the use more mechanistic interpretability approach, where the language where the language model parameters and tensions are probed in order to discover what happens within the parameters when the model is doing reasoning, or how the parameters change when the model is being trained. Yeah, so yeah, so I think that Pfolio more falls, actually both Pfolio and also brain teasers fall into this explanation paradigm, where we are trying to ask the language model to explain their outputs, explain and go beyond the final answer to say what it is, to understand what it is actually thinking. Yeah.
Mhm. And you also conducted that in this work. You've conducted that very close comparison on how humans versus machines produce those reasoning traces. What are the most significant differences that you have observed?
Yeah. So I think the most significant difference was that humans conduct this reasoning. We usually go with we sometimes we use actually a graph try to have a graph structure, like some visualization of the reasoning problem, instead of simply going going forward step by step. Yeah, and um uh, but again, when we write the reasoning chains, we need to write it in a step by step manner. Like, yeah, and I found that but for machines, especially for like symbolic engines, um yeah, so those symbolic frameworks, they use an algorithm to solve the problem, and when this algorithm is actually very different from human problem solving, since the algorithm is developed to solve problems at a very large scale with maybe like 100 or like 10,000 premises. And in this case, the algorithm would try to like maybe algorithm will have some for loop, and also yeah, and but in general it's very different from human problem solving strategy, mostly because that is designed to solve very large scale problems. Yeah.
So, in your opinion, how much understanding these differences inform the development of more robust and transparent AI systems?
Yeah, so I think that's a very interesting question. That how, yeah, so for to develop more transparent systems, I think the LLM should be able to explain its decision. Yeah, but at the same time, another line of being transparent and robust is to use the symbolic form. And by using the symbolic form, we offload part of the reasoning process to the to the algorithm, which are proven to be able to reliably solve very large scale problems. Yeah, and so I think this is another way to build robust systems. Yeah.
Right. It's also interesting how, to me at least, how this reasoning is. How does it relate to the consistency of those
Yeah.
models?
Yeah.
And
Yeah.
the consistency is usually a big part of trustworthiness for
Mm-hmm.
people.
Yeah. Yeah.
Can you elaborate a little bit on this?
Consistency, like outputting similar outputs every time we prompt the model. Yeah. Yeah. So I find that consistency in reasoning is very important. Yeah, very important problem. Like, for example, if a model that we are using every day just suddenly gets updated, like it uses another checkpoint, then it would change possibly change a lot of the decisions that it make. But I think this kind of consistency also requires some robust evaluation, where certain critical aspects, like certain like very deterministic tasks, need to always stay consistent, while certain tasks can have some are allowed to have some variance. Yeah.
Cool. Thanks. Very interesting. Let's now talk about Folio, natural language reasoning with first order logic. You designed this benchmark to translate reasoning skills into symbolic tasks such as first order logic and mathematical proofs. Why is it crucial to evaluate LLM reasoning in this symbolic domain, especially when many LLMs primarily operate in natural language?
So why? So I think LLMs primarily reason in natural language, partly because it's trained mostly on natural language, but yeah, but it's not very but we never thought about this question of like what that like in human problem solving, does the reasoning happen in a natural language manner or in a actually in a symbolic manner? Like I read some theories from cognitive science that say the reasoning is actually that happens in human is actually symbolic, and the symbolic actually helps creativity even more. Yeah, and also I think it depends on the type of reasoning problem as well. So I think roughly speaking, reasoning can be characterized as doesn't require any knowledge, like requires only relevant knowledge, or requires like general word knowledge and being very knowledge intensive. Yeah, so so it's like a very broad spectrum when it comes to the knowledge required for a reasoning problem. Yeah, and I think on the extreme end is the problems that like this math and logical reasoning, and on the other extreme end could be like common sense and also moral and emotional reasoning tasks. And to me, I think it's more straightforward. I think it's more straightforward to do emotional and moral reasoning, actually with natural language than with symbolic language. While for math and logical reasoning, it's more straightforward to apply symbolic reasoning. Yeah, yeah. So I think, yeah,
That's super interesting. And you have already mentioned your hybrid mind work before, and now I want to come back to that one because in this work you explore those complementary effects of neuro-symbolic reasoning and
yeah.
purely natural language reasoning, and see how it enhances like how those effects enhance LLM performance. Can you speak a little bit about the practical implications of combining those approaches?
Yeah, I think for I think those two approaches are uh in practice they work very similarly for a large language model. Like if we only use one of them, the performance is actually very similar. Both for earlier models like GPT-3, and also for the recent model like GPT-4o. Yeah, so that's actually quite surprising to me, because I felt that the model capability has shifted a lot. So maybe like it will be better at one of them. Yeah. So yeah. So and the fact that they are still similar, so I guess somehow show that they both have their advantages. Yeah, and we did a best of two performance, like when either one of them is correct, and we find that if we use that, is the performance is actually much higher than if we simply do one approach two times or even four times. Yeah, and that really shows their complementary advantages. And yeah, and I think that's performance wise. I think also in practice, some problems, as I mentioned, machines can do it better when it actually abstracts the problem into a symbolic form instead of, in that way it can it can just not think about the semantics while solving the problem. Yeah. And that is I think very could be makes the problem solving more efficient and effective.
So were there any specific scenario? You already said that they are they have some kind of a complementary thing. So in which scenarios does one approach complement the other most effectively? Like, do you have any specific or concrete examples based on your experience?
Yeah. So one type of example that's the I think can be divided into two types. One type is where the like semantics are actually very complex, but or could be the language can be very hard to hard to parse, but the logic is actually relatively simple. And in that case, whereas a language model that is, since language models, they are designed to actually understand natural language. So in this case, understanding the semantics helps a lot, and doing it in the natural language space helps. But on the other spectrum, where the logic is very complex, but parsing the semantics is relatively easy. So in this case, we find that you're doing it in the symbolic space is more helpful.
Sounds good.
Yeah.
Sounds good. And I think it's time for us to wrap up. It was really interesting to hear about all the different aspects of the work that you do in the area of LLM reasoning, AI, explainable AI, AI interpretability, complex reasoning, everything extremely interesting, and I really enjoyed that conversation. Looking ahead, what, in your opinion, are some of the most pressing open problems or most exciting research directions that you see emerging in LLM reasoning, interpretability, or the intersection of the cognitive science and the AI that you would be eager to explore further?
Yeah. That's a very big question. I think like making this kind of predictions, I feel is very difficult, and probably LMs can't do it well yet. But okay, I will try my best to give it a shot. So for one aspect I mentioned, I think is very important, is to maybe borrowing insights from human problem solving that the cognitive scientists have been studying for very long, to try to improve the data efficiency and generalizability of current large language models. Yeah, so that's one thing that we discussed. And but another area is, I think, is a long horizon reasoning, and I recently also worked on projects about doing legal reasoning, and in that project we try to we found that long horizon reasoning is part of the problem is it's very hard to evaluate. Yeah, and yeah, and so that really complicates the problem, and I think it's a very good research problem maybe in the next few years. And the third, maybe going a bit broad, just for this AI field in general, I find robotics very area that is worth doing a lot of research in, and because in that area there are a lot of open problems, and data is scarce and hard to collect.
Cool. Thanks for sharing that. Simeng, many of our audience are early or mid-career female researchers who are now listening to us. As a woman in AI research, what advice would you offer to these female researchers who are navigating the academic AI landscape, particularly those aiming to publish at top-tier conferences and do impactful research?
So as a female myself, I've actually constantly been searching for role models. I guess the most important thing is to build a support system. Because like I have worked with so many wonderful male researchers in my career, and actually so far all of my PhD advisors or like maybe undergrad advisor, even internship advisor, has been male, and they have been providing tremendous support and help in my career. But sometimes I find that I do find that talking with female researchers, especially since there are there are not many of them, can be a more rare experience than talking with male researchers. So I constantly try to find such support, and I think when we find that we are in an environment or system where we seem not to have enough support, always trust in yourself and find those support broadly, maybe in conferences. I think during conferences, reaching out to people is much easier, and scheduling meetings. Also, some researchers, they put that they are open to meetings on their website. So in those cases, it's also good to reach out. Yeah.
Yeah, that's useful. Maybe you could also share some insights that could be useful to those who are listening to us right now.
So I think personally, I have like I find some very senior female researchers very inspiring, and they sometimes can have like very practical advice for junior researchers. But in general, I find interdisciplinary support either from undergrad or from other PhD researchers, especially since like LM is becoming more and more broad. Support from other majors, like maybe not just women in AI, even women in psychology, and also other fields can be a very helpful support. But I guess in my field in general, like reaching out to female researchers who are working on similar topics especially helps. Yeah.
Cool. Thank you, Simeng. You mentioned this interdisciplinary approach, both in terms of research collaboration and also mentorship. And I think that's very inspiring. Sometimes we limit ourselves to this like small community of AI research, and it's good to open up both to get some ideas and also get mentorship from people who look at the world from different perspective. This was such an inspiring conversation. Thank you so much for joining us today. Thank you so much for sharing your insights with us and with our listeners.
Amazing. And thank you for joining us on this episode of Why AI. You will find more information about Simeng's research and publications in the episode description as well. So definitely check this out. And we will see you in 3 weeks with another deep dive with the women researcher pushing the boundaries of AI. Until then,